Start recording here. Let you guys see my screen. Okay. All right, remember last week when I told you that I would email you all out a chart that required the local altimeter setting?
No.
Yeah, I didn't do it because I didn't want to email it all out and then describe everything in the email and whatever. But here it is. I found one. There's actually a lot of them, but this one seemed the most appropriate. So this is Hayden, Colorado. If it ever pulls up. If I can get it to go big. Okay. So when local altimeter setting not received, use the Craig Moffett altimeter setting. I think it's just like a local, another altimeter setting of a place close. Increase all decision altitudes 100 feet and increase the visibility to 3/8 of a mile. So basically what that means is you're coming in, there's a lot of terrain around here. So if you don't have it, you could end up coming in a whole lot lower than you, or higher, I guess, than you anticipated. So being like way up in the mountains, that's pretty important just because if you came in and all of a sudden you were like 500 feet lower and than you thought you were, and you know, up in Hayden, especially a lot in the winter, there's a lot of fog that rolls in, or it could be heavy snow affecting the viz, and everything's white, and you're looking for a runway, and all of a sudden you just hit the ground. So, not really something that a dispatcher worries about. This would be more something for the pilots. Kind of like Wes was talking about, everything for the altimeter is mostly for the pilots, but just kind of interesting. So today we are continuing on with weather. Looks like you guys went into some METARs and some TAFs last week, or yesterday, sorry. How does everybody feel about those?
I feel like the more I do them, the better I'll get.
Yeah.
Agree.
Here we go. Okay, let's freshen up on a couple. Somebody throw out a couple of cities. Where do we want to fly to? I know somebody's going to say Honolulu.
Cincinnati.
And somebody's going to say Maui.
Oregon.
What is Maui's
OGG.
OGG? Let's do North Bend, Eugene. Somebody said Cincinnati. We'll do those. What was Maui's again?
Oscar Golf.
It's saying that.
It's OGG.
Huh. I may have the.
It's POGG, I think. Yeah.
Yeah,
Hold
I
on.
typed it in wrong.
Do Kona KOA.
Okay. And I don't want all this. Golly, Honolulu with beautiful weather again. North Bend's not give us anything. All right, who said Oregon?
That'd be me.
All right. Do you want to take this one away and read this one for us here? Can you guys see this? Maybe I'll make it bigger.
Yeah, there you go.
Okay. Is that better?
Yep. All right, so this is for Eugene, the 5th at 2254 Zulu. Winds from 040 at 4 knots, 9 statute mile visibility, broken cloud coverage at 6,000 feet, 31 degrees Celsius, dew point at 6, altimeter 29901, remarks AO2, sea level pressure 1125. Hey, is that haze? I can't remember.
Honestly, a lot of these remarks are not like super important. I actually don't know what haze or the HZ is.
HZ.
Yeah, that's haze.
Haze.
Cool. Haze.
I've never seen it in a remark. Honestly, most
Yeah,
of the
no,
time, people actually like when you start dispatching, you'll read basically all the way up to the remarks, unless this one is actually a pretty big one. The AO2, that basically just means they have a precipitation discriminator.
Okay.
But then this is like just the actual temperature.
And
So
then,
instead
yep.
of being 31, the temperature is actually 30.6. And then instead of it being 6 degrees for the 2 point, it's actually 5.6.
Sweet.
Hey, Davis, when we're reading aloud the temperature dew point spread, is there a particular phraseology that most dispatchers use? Would they say dew point spread is 31/06 or?
You just basically say like temperature's 31, dew point is 6.
Okay,
When we start
so
looking, let me see if I can find another one. I'll see if I can find one where when we reference the temp dew point spread, a lot of times what we're talking about, where was raining? think we have a big depression over New Orleans. So when you hear people talk about the temp dew point spread, God, that's not even a good one either. A lot of times we're referencing fog. Let me see if I can find some real quick. Be a whole lot easier in the morning. Maybe Dothan. I should definitely have known that. Great. Okay, 10 and clear. This is kind of when we're referencing the temp dew point spread. A lot of times what we're talking about is like, do we think it's going to fog? With a low temp dew point spread to where like this spread is 2 degrees. So we're not really looking at much of a, like that's a small difference compared to, Eugene, which is 31 and 6 right now. So there's not much of a chance of getting fog down there. But a lot of times people reference that they're talking about if we're going to be having fog. So like one of the things we were talking about is in the mornings, the coldest temperature in the morning is right after the sun comes up. So if you saw like, let me see if I can just find one. Maybe somebody took a picture of one time. Nope, not even close. If you saw like BR, like 10 and clear BR for like some mist, but the mist is not really, it's not really affecting much. And then you saw like a temperature dew point spread like that was 2 degrees like right before the sun came up. That's when you might start thinking about, okay, the temp dew point spread's only 2 degrees. When the sun comes up, it's probably going to drop like maybe a degree or two. And I bet that fog really thickens in. But just saying it, you'd say temperature is 24, dew point is 22. There's not much of a phraseology. Like, if I was going to read this one, I'd basically just say, this is Honolulu, on the 5th, 2253, Zulu. Wind is from 070 at 9 knots, gusting to 18. 10 statute miles of visibility, few at 2,500, scattered at 4,000, temperature's 31, dew point is 19. Our altimeter is 2990. And every now and then you have to read one off to a pilot, but there's not much of a phraseology. So don't necessarily worry about it, but if you do say something weird, I'll let you know.
I'm just mostly thinking as we come up on the practical that we say it in such a way that makes it look like we don't know what we're talking about.
No, as long as
probably that's anyway, but
no, as long as you know what you're doing, like know what each one of them is, like you could just say, few at 2,500, scattered 4,000, temperature 31, dew point 19. Like you could say it very choppy even if you wanted to, but there's not much of like a wrong or right phraseology. I wouldn't really reference the spread. But I mean, I guess you could say the temperature dew point spread is 31 and 19. But I would just say the temperature 31, dew point is 19. Is anybody who said Cincinnati? Let's.
I think that was me.
Katie, you signed yourself up for a big one there.
I know.
This is actually
I
a
know.
really cool one because the remarks are pretty cool. I hope I know what all these mean.
Perfect.
Sweet.
Um,
Why don't you take away this specie up here?
okay. The specie for Cincinnati on the 5th at 22:59 Zulu. Gusts or wind coming from 350 at 11 knots. Visibility is 10 statute miles. There's thunderstorms scattered at 4,200. I don't know what CB stands for.
Does anybody remember what CB stands for?
Cumulonimbus
Oh, yeah.
type of cloud.
Yeah, it's just the type
And
of
then,
cloud.
okay, then broken at 5,500, and then broken again at 14,000, overcast at 21,000, temp 26, dew points 20, altimeter is 3018. The remark is that it's an AO2.
So that's actually a wind shift. So the wind shifted at 22:39 Zulu.
Okay.
Yeah. And then we have lightning, distant, southwest and north, frequently. And then this is actually telling you what type of lightning. So lightning is ground to cloud. Cloud to ground and in cloud.
So that's not gusts in that?
Nope.
With
That
that?
is,
Okay.
so that basically just says lightning, ground to cloud, cloud to ground, and in cloud. And then that's in the southwest, the northwest, the north, thunderstorms. And then, yeah, southwest, northwest, north. And they're moving slowly. And then in the north, we have some showers in the vicinity, southwest and north. And then this is the temperature. So there's just a ton of stuff in there. Mainly what we're worried about here is this TS. So there's a thunderstorm. So chances are probably pretty good we're not landing at that airport. If we had a plane going in there, they would probably have to hold until the thunderstorms passed, or if they couldn't hold, they would have to divert. But most of the time, they don't land when there's thunderstorms over the field. Sometimes the thunderstorms aren't as bad as they're being reported, and they'll actually still land, like if it's just rain. But if there's anything convective, they won't land, just because if there is a cell that dies with that, we would actually have a huge downdrafts and updrafts, and it could, I mean, you could end up putting a plane down on the ground pretty hard, or even crashing. I know there was might have been an American flight that landed in Dallas. Delta 191. So they were flying from Fort Lauderdale, or yeah. stopping in Dallas. Over a mile short of the runway. Killed 137 people. And what happened is they got a microburst. Let me see, have we... Let's see if I can find one.
We watched a video on it a couple classes ago, I think.
Okay, cool. So then you guys saw basically how the wind can shift when you're flying through a thunderstorm. So if you're on the ground and all of a sudden a microburst, or you were close to the ground and all of a sudden a microburst hit, then it could slam you into the ground just like that.
So in a meter like this, when it indicates TS, is it saying that it's right over the field or that it's within a certain radius? What's
Right over the field.
distance usually?
So if it was distant, that's within 10 miles. Or vicinity, that's within 5 miles. But if it says right up here, TS, that means, yeah, it's right over the field. So have you guys talked about what constitutes a ceiling and what doesn't?
It's how much cloud cover if it's above 5/8, right? Or
Yeah.
just cloud.
So pretty much what we're worried about for a ceiling is either broken or overcast. So what's our ceiling here?
55,000.
Yeah, it's only the lowest one. This is the one we're worried about. I mean, although if this wasn't here, this would be a ceiling, and then if this wasn't here, this would be a ceiling. But this one, scattered, it's not too much. So actually this cloud layer, except that it's a CB, so that is kind of something we would be looking at. But just the cloud layer, scattered, we're not really too worried about that. I guess North Bend just doesn't have a METAR right now. Let's see if I can find some good METARs. Cincinnati was a good one. So I'll add those to the queue. Okay, who wants to take away O'Hare here?
I'll give it a go.
Alrighty.
Alright, Specie at O'Hara on the 5th at 2330 Zulu. Wind from 350 at 9 knots, 7 statute miles visibility with rain scattered at 1400, ceilings broken at 5500, overcast at 10,000, temperatures 24 degrees Celsius, dew point is 22.
Alright. Have you seen that one before? Whoops. This one is basically just telling you when the rain began.
Okay. So rain beginning. Okay.
Yeah, 22. Rain began at 22:58. So when we're looking at this rain and this rain, we've got this dash mark on the front, and that is basically telling us the severity of it. So when the rain began, a dash mark means it's going to be light rain. No mark at all means moderate rain. And then if it were a plus sign, it would actually be heavy rain. So when you're reading this off, you would want to say 7 statute miles of visibility, moderate rain, scattered 1,400. If there were a plus sign in front of it, you would say heavy rain. Okay, so this one's got some cool remarks in it that we can talk about. Who wants to read Colorado Springs here? Brian, you already read one, didn't you?
No, not yet.
Oh, okay. Why don't you take Colorado Springs then?
All right, so Colorado Springs on the 5th at 22:54 Zulu. A wind from 130 degrees at 6 knots, 10 miles visibility, scattered clouds at 4,100 feet, scattered clouds at 6,000 feet, broken clouds at 11,000 feet, broken clouds at 22,000 feet or 20,000 feet, temperature 16 degrees, dew point 12 degrees, altimeter 304.3, then remarks, the automated discriminator,
Precipitation discriminator.
AO2. Precipitation discriminator. You can
just say AO2. Don't worry about the remarks so much. Most dispatchers hardly even read these. What's important here is it does tell you
rain ended, thunderstorm ended at 1800, rain ended at 2900.
So this is actually 29 minutes after the hour.
Oh, 29 minutes after the hour.
Yeah. So that would have been at 22:29, the rain ended, and the thunderstorm ended at 18 after the hour. So we actually had a thunderstorm, and then it continued to rain for another like 11 minutes.
So when would they do like 29 minutes after the hour versus an actual time? Would it be if it happened within an hour of the METAR, or?
Just because these come out every hour, they don't have to put that it was 22:29. So this would be different if it were like the next hour. They probably wouldn't even reference it. So just, you know, because this only comes out. So when we're looking at our valid time for this METAR, when is this METAR valid till?
Till 23:54 Zulu.
Yeah, and then this METAR is basically useless to us. So we know that this is the 2200 METAR. So we would know that it's going to be 22:29 would have been the time. So just know that is
case earlier where it was RAB and then it gave an actual time. That was probably because the rain began previous to that METAR.
Yeah, it could have been previous to that METAR. And also some places you'll see do it a little bit different.
So when it says 22:54 Zulu,
Uh-huh.
is that METAR good for, or yeah, 20 right there, that?
Uh-huh.
Is that METAR good for, you know, the rest of until it says 2300, or is that METAR good for an entire hour? Like, is it at the top of the
So-
hour, or is it the entire hour from that time?
From this time. So you would assume that the next METAR is coming out at 23:54. Unless
Okay.
something drastically changes, and then a specie comes out.
Hmm.
And so up here, if we only had this METAR in O'Hare,
Hmm.
if we only had this and then we didn't have these species, this METAR would be good from 22:51 to 23:51. Well, then we had
Okay.
this specie come out. So now actually this METAR is almost useless to us. Now this specie is valid from 23:14 until 23:51. So it's valid until the next METAR.
Okay.
So this one's not necessarily valid for an hour. Species are not. They're only valid till the next METAR comes out. But then we had another specie that came out, and this one's only going to be valid for probably about 21 minutes. So from 23:30 until 23:51.
Okay, that makes sense.
Yeah.
All right, cool.
Casey, why don't you take away DFW for us here? This is Dallas Fort Worth.
Okay, so it's the 5th at 22:53 Zulu. It's degree 330 at 11 knots, 10 statute miles of visibility.
So when you're saying that, just say wind is from 330 at 11 knots.
Okay.
Yeah.
Few clouds at 11,000 feet,
Mm-hmm.
and then scattered clouds at 12,000, broken at 15,000, and then more broken at 25,000. The temperature is 27 and 22 degrees dew point, and the altimeter is 29.99.
Nice. There's actually a
Did you want me?
towering cumulus cloud in the distance.
I was gonna say I'd have to think about the rest of the remark part, you know.
Yeah. So CB, distance, cumulonimbus, distant, northeast, south, west, northwest, and it's moving.
Okay.
So this storm system is moving northwest, and there's a towering cumulus in the distant northeast, southeast, and that's temperature again.
Is it moving from northeast to southeast? Is that what that means? Like TCU distant northeast to southeast?
See, distant northeast.
Yeah, right where you're at. The
Yeah.
north and then south and west and northwest. So what can you dissect that? What does that all mean? Because that's just
So that
the whole...
basically just means like where these clouds are. And
Okay.
they're all moving to the northwest, which is
Oh, okay.
really weird.
Yeah, there's a lot of directions there. I'm like, okay.
Yeah.
I'll just be going in a circle. So, okay, cool.
Let's see. Are there any other good ones? Let's see if these are any good. All right. Okay, so this is Moline, Illinois. It's in Illinois, like right here. I was hoping to get a thunderstorm, but let's see. Katie, you read one. Wes, you read one. Paul, do you want to talk to us about Moline here? Or did you already read one?
Sure. No, I haven't.
Okay.
Okay, so we got Moline on the 5th at 2352 Zulu. Winds coming from 20 degrees at 3 knots. 7 statute miles visibility with light rain. Few clouds at 6,000 feet. Few clouds at 75,000 feet. Broken clouds at 12,000 feet. The temperature is 23 degrees and the dew point is 22 degrees. And the altimeter is 30.14.
Nice. All
Let me
right.
do the reminder.
No, don't worry about those. There's not really much in here that's good. So when we're talking about these clouds, is this ground level or is this going to be a mean sea level?
Mean sea level.
Mean.
It is. This is actually, these are going to be above the ground level. So these clouds in the METAR. So that way we don't have to do any math on the elevation of the airport and then trying to figure out where the clouds are actually. So because when we're looking at our approach charts, let's go back to Hayden. It's actually not going to work at all. We'll just go with this Kansas City actually. It's thinking. It's thinking. Okay. So we've got our airport elevation up here. We'll just say it's, well, 1,027 feet. So when we're looking at this one, and we have few clouds at 400 feet, those would be, if this was in mean sea level, those would end up being below the ground. But then this would end up being 1900. I was trying to find one with a like low ceiling, like a overcast 400 or something. But yeah. So basically when we're looking at this, these METARs are going to be above the ground level. Let's see. Preston, did you read one already?
I have not yet.
All right, why don't you read us the rest of Kansas City? This top one here.
All right, so Kansas City on the 5th, 2353 Zulu. Winds coming from 50 degrees at 4 knots, 10 statute miles visibility. A few clouds at 400 feet, scattered at 2,900, broken at 6,000, overcast at 13,000. 23 degrees with a 22-degree dew point. And the altimeter is set at 30.11.
So this is actually one of those ones where we're kind of looking at our temp dew point spread is only 1 degree, and we're kind of seeing that in this cloud layer here. So this is a really low cloud layer. Half the time when you see something like that, you also see them reporting fog or maybe some mist. It's not a real strong layer though. If it were like broken, they might end up being reporting also some fog or some mist. This is a pretty low temp dew point spread. A lot of times you will see some fog around that. In fact, all these have a pretty low temp dew point spread. So I kind of picked them based upon this big front right here, this cold front moving across. We'll talk about a bunch of aviation charts after. I reckon we'll take a break once everyone reads a METAR, and then we'll come back and talk about a bunch of aviation charts and talk about that front that's moving across. Tara, you haven't read one yet, have you?
No.
All right, why don't you read us Hayden?
Okay. Where is Hayden?
Hayden is in Colorado. It's a big ski destination, actually.
Cool. Is it like up above Denver? Is it by like
It's like
Longmont?
northwest of Denver, I think. I hope I
Okay.
didn't just lie to you, but well, it's not coming up. get there.
Yeah, it's cool.
Yeah. So yeah, just northwest of.
That's probably about 2 hours away, though.
Yeah.
Drive. Anyway, sorry.
Yeah. Anyway. I don't think the town of Hayden itself is a big ski destination, but I think people fly in there and then go.
Hmm.
All right, so Hayden.
Okay. Hayden, it's was put out on the 5th at let me make it bigger, at 23:56 Zulu. It was an auto.
That basically just means like a machine pumps them out every hour.
Yeah. Coming at, I don't remember how to
The
say
wind
it. The
is from
direction
040.
040 is the direction the wind is from at 8 knots, 10 statute miles of visibility, clear. The temperature is 22 Celsius. The dew point is 03 Celsius. And the altimeter is 30.32.
Yep. That one was almost as hard as Cincinnati.
Not quite.
All right. Trevin and Tyler, have you guys...
I have not.
Where do you want to go?
So I'm done.
I don't know, Florida, New York.
Florida or New York? Those were big differences there.
Make him do LaGuardia.
I did. Although I think LaGuardia is nice right now.
Yeah, I was gonna say Chicago had a lot of problems today, but out east didn't seem to have too many issues.
God, LaGuardia was the New Yorks and Chicago were a mess the other day.
Really?
Yeah.
I just got back from a 10-day vacation, so
You actually
today was my first day back at work.
Yeah, you missed some doozies.
I'm glad I was gone.
Yeah, there was actually probably the hardest. What was it? Monday was probably the busiest day of dispatching I've had in over a year. It was insane. There was a huge thunderstorm system that was pushing through O'Hare. Like it pushed through O'Hare, and it was just like crazy thunderstorms, and they kept popping up over O'Hare, and they would just like move over into Detroit. And I mean, this entire just like a big line of thunderstorms that just sat right here, and they kept moving over to Detroit, and then more would pop up at O'Hare, and they were just both in ground stops and ground delay programs all day. And it seemed like we had a bunch of New Yorks that got delayed, and then when they went back to LaGuardia had already closed, and so they had to divert to JFK. And then the next day I came in and I had like a bunch of JFK to LaGuardia reposition flights and stuff. It was a mess.
Sounds like you had a good time.
Yeah, it was a good time. Kept me on my toes.
Yeah.
All right. LaGuardia is a pretty easy one.
All right, so LaGuardia on the 5th at 23:51 Zulu. The wind's coming in at 170 degrees at 10 knots. Visibility is 10 statute miles. There's a few clouds at 2,500 feet. Sorry. Yeah, 2,500, right?
25,000.
25,000. Temperature 27, dew point at 22, altimeter 30.16. I don't notice anything standing out in the remarks.
And then Tyler, you already did one, didn't you?
I did.
Yeah, I thought so. Let me see if I can find any particularly good ones here.
Wasn't there like a tornado in Mobile, Alabama?
Alabama?
Yeah.
I don't know. There might have been. Those are actually really interesting sometimes because I used to always watch for different like tornadoes and hurricanes and stuff, and to see what the METAR reports during those. And most of the time during tornadoes, they just don't report. There's just like nothing. So
Why not?
most of the time they evacuate the tower, and everything just like shuts off.
Oh.
So the last 20 METARs. Not seeing one. There's your temp dew point spread you don't want to see.
Nope.
See, at one point they went down to 1 statute mile visibility. It's probably this morning. Yep. Yeah, that was this morning.
What does ALQ mean?
All quadrants.
Huh, well, that summed it up.
So that means like if you divided the sky into quadrants, so northeast, southeast, southwest, and then northwest. No. Oh. So these would be your quadrants.
Oh.
This would be. It's a beautiful E. Northeast, southeast. You get the point.
Yep.
So basically what they mean is there's CB, it's cumulonimbus, clouds in the distance. So we'll call this a 10-mile radius. So they're distance 10 miles, and so they're all around.
Interesting.
Well, it got down to a half actually. That's probably when that tropical depression hit, actually.
Yeah, because if you look at how low the clouds were right then.
Yeah, although it's not very windy. Actually, this is probably when it hit down here. 45 knot gusting winds. Wind shift. Yeah, so that basically, I mean, this is probably around when it hit. And then, let's see. Yeah, so then we've got pretty low pressure. So 2982, 2984, 88, 89. You can see it starts climbing. So then you can tell it starts going away. 2994. So the pressure rose pretty rapidly there. Where is that thing right now? I think it's basically all done, isn't it? That thing just scattered out, right?
I think so. I just watched it on Snap Maps.
So now the next one is building. and it's going to come, and we'll see what happens with this one. At least it's not hitting Puerto Rico again. It's Puerto Rico that got hit really hard, wasn't it?
Yeah, it was like all the way across the island, like the whole
Yeah, I think it
straight
basically just like went
across.
straight up here and then hit Hawaii. That's probably like South Carolina right there. So it might come. This one might. I don't know if it does. It'll probably just skim it and then go back to the right. But when I come back, look at a bunch of weather charts and stuff. But as of now, let's take a 30-minute break. And why don't you come back at 7 o'clock? Okay, yeah, half of these charts nobody uses, and the other half they use infrequently. There are a few that everyone uses all the time, but we'll go over some of these. So basically the first one we'll probably go over is the surface analysis chart here. So this one shows all sorts of stuff. So first off, we've got all these, you can see the clouds, the white. That's a satellite view. Then we've also got radar, the green. We have low pressure areas, high pressure areas. We have our cold fronts, stationary fronts, occluded fronts up here. This is actually an occluded low when they come in like this. And this is typically like pretty bad weather. Sometimes we get those further down here over the Midwest, and they kind of wreak havoc on us. There's a lot of stuff on this though. Like you can also see like this 1024. That is, they're talking about pressure gradients here. So when we're looking at these close lines together, it'd be a higher pressure gradient, whereas the ones that are further away are going to be lower, or a lower pressure gradient. These are kind of just cool. They give you like a brief look of kind of what's going on in the United States. So if we're looking at this, if it were, well, I guess it's evening, so there's still some heat in the air. But this big cold front right here, and we can see all this rain. We're probably going to have a lot of thunderstorms right in this area, and probably a lot of rain is going to come with that too. Like you can see all these clouds as well. If you remember, Moline was down here. They had pretty bad weather. Cedar Rapids we looked at was right here. It had fairly bad weather. Kansas City, they had, I guess, yeah, they had some lower clouds. I think they were like scattered at 400 or something. And we had a lot of rain right through there too. So we can kind of see that a little bit here. Most of the weather we have is going to be associated with fronts. Also down here we have Gordon that came through. That was that kind of, I don't think it ever became a hurricane, but it was like a tropical depression. But we can kind of see some stuff that happened with that. Most of the time, high pressure areas are associated with better weather. Not all the time though. So low pressure, the air is rising. You can get a little bit of a lift factor out of that. So we'll check out the weather depiction chart here. A lot of this is basically going to be very similar, but we can see down here we have MVFR and IFR. And then, you guys know what MVFR and IFR really kind of stand for?
Visual flight rules and instrument flight rules.
Yeah, so this is, moderate VFR. So MVFR is ceilings like 1,000 to 3,000, and then visibility is 3 miles to 5 miles. And IFR would be ceilings like 500 to 1,000, and visibility of 1 to 3 miles. And then VFR is greater than 3,000 foot ceilings and greater than 5 miles of visibility. So this just kind of shows you areas that are going to be typically in VFR. This is what I was looking at to try and get bad weather for those METARs.
So this odd red R, is that the IFR, or if
That-
we're blue with
That is
VFR?
actually a thunderstorm.
Okay.
Yeah.
So where's the actual VFR and IFR indicators?
That's
they're supposed
the blue and the red.
Oh,
So
that's
like
just
this
the big
blue area right here. That would be in VFR. These little speckles of red, that's going to be where it's IFR. And this is basically just saying that it's SIGs, thunderstorms. I believe if I remember correctly, the 2 dots is rain. I think. I'd have to go back and look that up now. But yeah, it just kind of shows, and it's still like high pressure, low pressure areas, and a couple of fronts that they're depicting on here. All right. Another kind of similar chart here would be the low-level prog is kind of a similar chart to the weather depiction. So this is going to be like a low-level prognosis of what's going on. This one is for 12 hours. So this kind of gives us a little bit of a heads up on like what's going to happen, where these fronts are going to be moving, that sort of thing. This one you can actually move out further. So you could go 24 hours. And there's actually a lot of dispatchers who will do this to look at their next day. And those people are crazy. I did it once and I swore it off forever. It was last summer and it was like I had like a really bad day. And I was like, man, I wonder what tomorrow's going to be like. And I was like, well, maybe I'll go look. And I went and looked, and the next day was supposed to be just as bad. And then I dreaded it all night. And sure enough, the next day was really bad. And it just made it so much worse. So now I've totally sworn off looking ahead to the next day. But some people do it. A lot of people use it actually for flying non-rev. So like when they're, going different places, they might look ahead on this thing and see what kind of, if there's gonna be like bad weather or something, then it might cancel flights. Another big one we'd look at would be convective sigmets. Most of these charts you can have overlaid over, like at SkyWest, we have most of these things overlaid over our flight following system. So I know when all these are popping up, these sigmets, these are convective sigmets. So it's going to be like areas of thunderstorms and areas of, probable thunderstorms or where they're very likely to like be about to form. Most of the time, though, it's just areas that have a lot of thunderstorms in them. We also have our watches. So this would be for, unfortunately, there's nothing on here. This would really only be for like tornadoes and severe thunderstorms. But this would put up for areas that we'd be looking at that may end up having stuff like that. We've also got the surface weather prog down here. So this one actually goes out even further. So this is also another prog chart that people will use to look to the next day. And I'm actually almost kind of mad that I did because I work tomorrow. But this is a big one. So like, and it gets, so like 48 hours in 2 days. It gets to it's not super good at predicting that far out. Like, once you get to 2-3 days out, it's not super accurate, but you can keep looking. That's in 120 hours. I guess they're saying that cold front's going to keep shifting down here into the southeast. Probably end up with an occluded low in here. And the winds are going to be pushing this down around like that. And we'll probably end up with some thunderstorms. They just kind of keep moving down into here. This one is one that everyone uses. Not this one. The TCF. So this is actually one that we use constantly as dispatchers. I actually have a whole separate tab for mine pulled up when I'm at work. And I keep it pulled up on aviation weather. So this chart is for within the next 4 hours. That basically saying there's going to be thunderstorms in here, there's going to be thunderstorms over here, and there's going to be thunderstorms over here, and down here and here.
Done for anything in particular?
TCF is Thunderstorm Collaborative Forecast. So you can see where it's like this big line is, big red area, and there's also another area within it. When it means that means that it's going to be even thicker thunderstorms down in here in this second area, but there is going to be scattered coverage through this whole thing. The red number here, 390, so that's going to be like the tops of the thunderstorms. So here they're not expecting as big of thunderstorms, 340, and this would be 390. O'Hare is probably a mess right now dealing with all these. They're probably on, I would bet they're on a ground delay program right now. A lot of their arrivals and departures go right through here. Almost everything from the East Coast goes through here. So they've probably got big reroutes coming up through here, and then like O'Hare does this thing where like even though there's probably no thunderstorms here, they won't route people through here. So they may actually be making like Nashville go all the way out here. But that would be like a published reroute. they're pretty notorious for sending people all the way out here to the east over Kansas City and then up from there. Just a very busy airport, so they end up using a lot of airspace. But when you're looking at this, so if you had a flight from Omaha to Nashville, you don't want to just send them right through this. Like this is going to be, I mean, if you could get way up over it, but none of our planes are, our CRJ 700, it's not going to get up over this. You basically would just want to plan around this or plan to the edge of it and give them some extra fuel. You know, this might be scattered enough that they can just pick through it. But typically you'd want to plan around this and try and stay out of these because this thunderstorm model is really good. If they say there's going to be thunderstorms, 99% of the time there's going to be thunderstorms. So the one that I use typically is this one. It's the same thing, the TCF, but this one shows you for more, it gives you the 4 hour, the 6 hour, and the 8 hour. So this tells you this is good until 5Z, this is good till 7Z, this is good till 9Z. And I like to look at this just to see, okay, are these thunderstorms building? Well, no, they're probably not. They're going to start dissipating. So if I have like a really long route or something, I sometimes look into this sort of stuff, or especially for ground delay programs where I have a flight that gets delayed like 2 or 3 hours. I might look into the next one just to kind of see, okay, what's it supposed to be doing? But yeah, when you look at these, this one actually gives you a little bit more of a information on this. So those 3 9s, what we're looking at is we're looking at thunderstorms at the tops of 3.5 to 3.9. So they really only give you 2.9, 3.4, 3.9, and then 40. They don't give you like really specific heights, but it gives you these overall ranges. And then as you can see the shading, so this would be sparse coverage, and then this is medium coverage. Medium coverage you definitely don't want to fly through. It's typically really thick. And then if it's just a horrible day, they will put a purple line, and that just means there's just a solid line of thunderstorms, and there's just no way. But sometimes if it is like sparse coverage, like right here will be probably pretty heavy, like medium coverage is what they're saying. And then if it's a big cell up here, sometimes if there's space through there, ATC will just route you through there. But most of the time, you want to just go ahead and plan to route around it. It does mean that your aircraft is going to take longer to get to the destination, and you'll actually see some delays for aircraft routing and stuff like that. Trevin's probably going to be really annoyed that I say this, but just don't so much worry about that. What we're worried about is safe flight. So if it takes a delay, it takes a delay. But you will see that though a lot of times when there's weather. Sometimes like when there's a whole bunch of weather, like right by Atlanta, or actually O'Hare is a better one because these will take huge delays. I almost guarantee that there's a reroute right now from Nashville to O'Hare, and if these thunderstorms are real thick, they normally this route kind of goes up here. But if those are real thick, they may end up rerouting them all the way over here to Kansas City and then back up to O'Hare. So that might like double the flight time. So like if you're ever at the airport and you see like a whole bunch of thunderstorms like this and your flight's delayed, that's probably what it was. Something like that. The worst though is actually when you end up planning for that and then they get up in the air and then ATC just like clears them direct, and then they have to burn a whole bunch of fuel so that they don't land overweight. It's hard. But this TCF is a huge tool that everyone uses, and I actually have a whole tab to it, and most of the time if you walk past my desk in the summer, a lot of times this is up, either this or just this page, which just has all the weather on it. But yeah, the TCF it's probably the most used tool that I have during the summertime. During the wintertime, we don't get too many thunderstorms, but in that we also have the severe weather outlook and the thunderstorm probability charts. These are kind of cool. This basically just kind of gives us like areas where there might be thunderstorms. So it gets a little lighter up here. Just kind of different areas. Thunderstorm probability.
Yeah, that's showing you actual thunderstorms, but would like the severe weather outlook, would that show you clouds that are still kind of big and billowy you still want to avoid?
Well, this is just a forecast. So like if you went in, so let's put this is basically looking more toward like tomorrow morning. And like kind of tomorrow, this is the forecast in the next 24 hours, like what's everything going to look like? And it's basically just saying we're forecasting that within the next 24 hours, these areas are going to be prime for having thunderstorms. We're in there. I'm sure you guys have seen a bunch of clouds around all today. There's a lot of Virga today. Driving around, you could kind of see big clouds, big rain clouds. But yeah, it's just kind of saying the conditions are going to be pretty prime in the next 24 hours to have some sort of convective activity in these areas. So this is more just a forecast tool for like a longer period of time. And then you can, like this one goes out to 48 hours, but I don't think I've ever really looked at it in the 48-hour one. Thunderstorm probability is a very similar chart, although this one gives you more probabilities though, like really where is it going to happen. And this one also, 12 hours, 24, 36, 48. This one will actually give you the percentages. So if we look in the next 24 hours, there's some pretty good percentages for, we'll probably have some thunderstorms in here. So we've got our winds aloft here. This one, I look at in the winter more. I'll start at kind of 18,000. Remember how we were talking about during the winter the jet stream moves down further south and also lower in altitude? Well, it does. So a lot of times during the winter we'll end up having a jet stream that's going straight across the United States. Somewhere it's going to curve. Maybe it comes down like that. Maybe it comes here and then swiggles down. Sometimes we get one that comes up from here, blows across that way. But majority of the time, at this 18,000 feet is where we start seeing, okay, this is where we're going to be doing most of our flying, is 18 and above. And this can actually affect some of our fuel burns. And it's like you can see up here in the jet stream, a lot of the strong wind is right through here. So if you had to plan a flight and it was totally weight restricted, and you were flying from like here to here, sometimes you can actually plan like a little further down, so they're not going into as much of a headwind, and then maybe back up. I've done things like that before, and you end up being able to put more passengers on. But it's kind of a long shot. Then you can go up from there. You can go to 30,000. Here we go. We got some better wind up here. So when we're looking at this, these arrows are going to be pointing to where, think of these as like an arrow. So this is like the feather on the back of it. So if this were like shot by a bow and arrow, like it's just got one feather on the side. So typically our weather over the United States always moves from west to east. So that's because the wind is blowing it from west to east. So this is wind is coming from the west. And when we look, each one of these long bars is 10 knots. And then the half bars are 5. So we've got 1, 2, 3, 4, 4.5. So this is 45 knots of wind, basically coming from straight west. And then our triangles here are, what'd you say?
I was just asking about the triangles or the flags.
So these are actually 50 knots of wind. So right here we've got a triangle and a long bar, or a full bar, I guess. So that's 60 knots of wind. Up here, we'd be looking at 2 triangles and a half bar. So that'd be 105 knots of wind. It's actually pretty windy over here. 120 knots of wind.
What are the numbers?
Temperatures. Down here you can see, a lot of times down here in the bottom left, it'll give you kind of some just different information. But yeah, those are just temperatures. So it's pretty cold up there.
In the southeast of the map, where like above Cuba, where it looks like it's all going around, is that because of Gordon? And then kind of up over Alabama and Mississippi, it looks like they're kind of going randomly all over the place.
I think this one is because of Gordon. Gordon's the one that just hit right here, isn't it?
I think so, yeah.
Yeah, I think this one is from Gordon. But actually, most hurricanes are not that tall. So if we went up even like 4,000 feet, you'd probably see, well, that one still kind of swirls. It starts to kind of break up. There's not as much spinning. There's just as much spinning down here, but this one, I don't know. I haven't really seen if there is a. I thought it was a little further out. Looks like there is a bit of a cell there. That might be a. Well, yeah, because Gordon's a tropical depression now. I'm not sure. It looks like it would have been some sort of tropical depression or a hurricane building. We'll see. I guess maybe we'll see within the next few days what's going to happen there. This winds aloft forecast looks a lot neater in the winter. So a lot of times, even when we have thunderstorms in the winter, this jet stream, think of like these are down here. And I mean, it might be like 30,000 feet, and we've got like 120 knots in the jet stream, and it just shears the tops right off of thunderstorms. So it might be like a thunderstorm below 30,000 feet, and planes are just flying right over them. Just because the wind is so much faster when the jet stream is flying over those thunderstorms that it'll actually just take the tops right off of them. So it's kind of a neat thing we have that goes during the winter. Let's see. This one, it's kind of just cool for when we have like hurricanes and stuff. There's really not much anyone uses this one for. Sometimes when hurricanes are really in full force, sometimes at work when it's like slow or something, I kind of stalk them just to see where they're at and see all the wind reports. There was one that hit Miami last year, and it was actually really cool to watch the METARs change. And because it went from like, as soon as it hit, the METARs were, I mean, the wind started going pretty fast, and then the winds got up to, I can't even remember what they were gusting at, but it was insane. And you could see the temperature and the pressure would change as the hurricane went right over. It was almost like the eye went right over, but just barely missed it. So you could see all the pressure changes and stuff, and it was really cool. Sometimes these freezing levels are interesting because if you have like some sort of no icing aircraft, you can come on here and see where there's going to be freezing levels. And then, you could fly like below that or something. For those two, we also look at these air mets. So air mets will put out icing, turbulence, and viz. So this is all three. Most common one I use would probably be icing or turbulence. Visibility, most everything we look at is just going to be the text-based stuff, the METARs. METARs and TAFs, and that's most of what we base stuff off of. If something looks like it might not be very good, that's when I end up a lot of times coming to these av charts and looking, maybe looking to see if there's low pressure or high pressure over something to see. But so we can come and check this icing. So if we had an aircraft that had an MEL on it that didn't allow us to fly through icing, I mean, right off the bat, we wouldn't fly through this. From 14,000 to 27, that'd just be a big no. That's where that big front is, all those clouds. There's a lot of clouds up in front of it too. And a lot of this is real cold because that cold front is moving through. Turbulence for air mets is typically for smaller planes, like general aviation. my favorite turbulence tool actually is on this hazards page in the flight plan guidance. So this actually will give you a lot of cloud layers and stuff. But then when you look at the green, that's our turbulence. And this is probably the most accurate turbulence tool that I've seen with talking to pilots and planning flights, seeing PIREPs. This is probably the most accurate one I've seen. And you can actually change this one to forecast for 3 hours, 6 hours. I probably wouldn't go past 3 hours looking at it. Maybe 6 hours. Denver's basically just like always turbulent. ACARS to pilot not too long ago, and I was like, hey, because one of these popped up over Denver, and I was like, hey, looks like it's going to be turbulent from 3.7 to 2.9 when you get into the Denver area. And I told him a point on his thing, and he sends back like, haha, welcome to Denver. Denver's almost always turbulent. You can always come in here and check out the hurricanes and stuff too. Those are cool to see. So like this one will tell us a little bit more depression on, or a little bit more information on the depression, Gordon, and where it's going to move. So you can kind of see, so Gordon came in from the south here, and then you remember the Coriolis effect, how everything goes back to the right? So he came in, and then all of a sudden, he's going to end up going back. Everything always ends up, that one that's coming from down here will probably end up doing the same thing. A lot of these ones don't end up going up that high. Some of them do, but most of them just kind of skirt and they go up the coast and they go out. And then there's this gives you some winds and temps, but mostly we just use that other wind and temp. We go over here to satellite. So the visibility one is, or the visual one is always really interesting, because if you look at it like first thing in the morning, so like I start my shift at 5 a.m. so the sun's not out yet. So if I ever look at it, it looks great. It's like, man, it's no clouds, nothing, just totally clear. But as you can see, the visibility or the viz one is only works during the day because it's based off of what you can see. Then if we look here, we can see, and this is the more infrared one. And it shows you where everything's at. It does look like there's something spinning down there, Brian. Something's going on down there.
Yeah, I see that.
That's kind of our satellite look at what's going on. You can change these to whatever. Or we can go and look at the radar. On this page, we actually have a 5-minute radar. So it means it updates every 5 minutes. And we can play it. So if we wanted to see what's going on, you can actually zoom like way in, play it, stop it. So a lot of times with radars, we get some weird, funky lines like these. And you can see that's just like where the radar goes out. So it's not always like 100% accurate. Sometimes there's just like random kind of like just lines that appear from weird things in the radar. So the 5-minute one's actually pretty cool to look at sometimes when you're like really sweating it out. Like if you've got a flight going into Peoria and you see those cells right there. You're like, oh no, are like those going to hit it? Radar summary is pretty useful though. This will tell you where there's some big cells. Hail, we can't fly through that. You guys ever seen hail damage on a plane? People fly through it all the time, like on accident. And it's we'll end up with damaged planes. These are some really bad ones. Can you imagine how loud that was? Yeah, I don't think I'd really want to be on that plane. It's probably really loud. And then they still had to land the plane like that.
How much would it cost to replace the nose like that? All that?
Oh gosh, I don't even know. Probably,
Like, would they have to replace the whole thing, or just could they patch it up, or how does that even work?
they probably had to replace the whole thing. I don't know. But then the windshield had. This
That
probably
nose
cost.
cone. So there was a bird strike in St. George from Denver, 8 months ago, and they like that where it's black there. That's just one piece, and they just replace that nose cone. I don't know how much it costs though.
I would bet that this damage is well into the hundreds of thousands.
Easily.
Because they probably also had a bunch of bent fan blades. And they had to go through and they probably had to fix all those or replace them. Yeah, this thing had to get replaced, I'm sure. The windshields had to get replaced.
It's insane.
Probably all sorts of the pedostatic, all those things probably got just knocked off. Plus, I would bet they sent some coupons to the passengers. This is a pretty famous one. Probably what happened here is they were flying at night. So if we go back to here, maybe they were flying and, just happened to be flying over a hailstorm and didn't see it building up ahead, and maybe they didn't have their weather radar on or anything like that, and then all of a sudden they realized they were flying right over a thunderstorm and hail was just blowing out the top of it, or they could have flown right through it. So it always, when they're flying at night, it's always a good idea. When they're flying during the day too, you also need to tell them like, hey, there's thunderstorms coming up in, 100 miles, whatever. But when they're flying at night, you also have to keep in mind that they can't just look out the windshield and see this stuff. So during the daytime, if there's a plane flying right over Detroit, like 34,000 feet, and they're flying, I don't know, somewhere up here, maybe they're flying up to Green Bay, they would be able to see this, and then they could, go around it. They could go through this little spot right here. But if they're flying at night, they're not going to be able to visually see this. They'd have to be using their weather radar. And so it's always a good idea to give them a heads up. Hey, there's some weather coming up ahead, and then you can turn on the radar and you can tell them maybe head toward something, JXN. And they could head down here, maybe through this little gap, and then back up. But I would bet that's what happened. I actually haven't read the story on it in a while. But all right, sorry. And hail damage happens pretty often. Just not, it's typically not that bad. It's big 7.4. Hit some. I wonder if we can find that St. George bird strike. Have you guys ever seen the deer strike?
No.
Yeah, PSA hit a deer. I thought it was PSA. It was in Charlotte. I thought there were better pictures. Yeah, I mean, a plane hit a deer, so. It probably caused a lot of damage. My girlfriend's dad used to fly F-16s, and there's a picture of him sitting next to what used to be a deer, and he was making a night landing and hit a deer with an F-16. And clearly it's not going to really do much to an F-16, so most of the damage was done to the deer, and it didn't suffer. It was gone. It got obliterated. But actually, deer running out into the runways in some smaller airports it happens. Back to weather, I guess.
Well, how big of a problem is hitting a bird or birds
It
hitting
happens
a
all the
plane
time.
or
And most of the time, it's not a problem at all. You get calls from
Really?
pilots, yeah, and they say, yeah, we had a bird strike on landing, so we're gonna have to have maintenance come out and take a look. It very rarely ever goes through the engine,
Oh.
and like if you're talking about Sully, yeah, it would very rarely go through the engine, and I mean, clearly it's only happened to one flight where it went through both engines. It would have to be pretty much on takeoff or landing. I mean, birds don't fly that high, but it happens all the time where they'll hit the wing or hit, nose cone or something. But I mean, you wouldn't even know as a passenger.
Huh.
Well, for a lot of them, yeah, you wouldn't know. But then basically what happens is, maintenance will come out, check it out, make sure there's no damage, and if there is damage, then they'll fix it. But yeah, it happens pretty often. It's actually more of a problem in smaller planes, like prop planes, because they're going a little slower, and so if they hit one, um, it can mess them up pretty good. I know it comes out fairly often that people die from bird strikes in like real small planes, where they hit a bird with the propeller, and it's like, I mean, you would definitely feel it, and then it can do a lot of damage.
We won't have to worry about it too much, really.
No, you'll hear about it happening all the time. So on the aviation weather, um, this stuff is anybody can access this. So this is also pretty cool. This has most of the same charts on it. So forecast convection, that's where I always get my TCF from. It's the same TCF. It's not like it's different. It just, I don't know. I like having the 4, the 6, and the 8 right here. Let's check out some PyReps. So the summer for PyReps is kind of boring. So we can see graphical depictions on these screens. So as we're looking at it, I mean, we can clearly see the colors are already going to be, green is light, orange, light to moderate, and then red we get to severe and extreme. So like right here, we have an isolated light PyRep. It looks like 33,000 feet. And then somebody else had a, I guess that would be, looks like 2 pyreps. And it's just hard to see. We're not going to go into that. One's light, one's moderate, or light to moderate. Over here, we'd have a moderate at 32. Most of the time we see these pop up and we can actually, on our flight following software, we just hover over it and it reads it out graphically for us. Or not graphically, textually. I believe. Let's go see if we can find some. Thought we had a, here, pyreps. Where has turbulence right now? Okay. Wonder if it's going to let me do that. So this is basically just the Chicago area, ZAU, Chicago Center. Maybe we'll get some good pyreps. And maybe not. Here we go. So somebody just actually reported sky coverage. That's not a typical pyrep that you see. But they said it's overcast at 900, and they did this on during descent on final 2. That's actually one of Chicago's runways. It's hoping for here we go. This one's not bad. Okay, so when we're looking at these, UA is just a regular pyrep. So then the next part we're looking at is where is the pyrep? Have you guys gone over this yet?
Not really.
Okay. So basically
UA, he hit a little.
who hit it? Who did?
Garrett.
Okay. Yeah. So basically, just when we're looking at this, it's okay. So we've got a pyrep. Where is it now? So here is over. So it's 45 miles to the east. So 270045 or 270045. So 45 miles to the east. So if, well, yeah. If this is PMM, we've got 270 is probably like this, and this would be 45 miles. The pyrep happened here. Do you get how that works? Okay. So time was 0011 Zulu. Flight level 11,000 feet. And type of plane would be, this is probably so an E75L. I'm betting that's probably an Embraer 175. That might be one of our E-jets. And then it'll say what's going on. And then it'll say, so this is icing, light, and constant chop. I gotta find more. I thought there were
When
gonna be
it
more.
says 45, oh, sorry.
Go ahead.
When it says 45 miles east, how is that east? I don't understand that. It
So
seems like it would
270.
be.
So when we're looking at, if we were looking at a compass,
Mm-hmm.
the top is going to be 0. Over here is going to be 90. Down here is 180. This would be, this is 270, isn't it?
Mm-hmm.
Yeah, 270. So it's just like our wind. So if our wind is 090 at 10 knots, that means our wind is 10 knots coming from 090. So it's blowing this way.
Oh, so from degree 270 east.
Yeah. So from
Okay,
degree
okay.
270. Yeah.
Okay, so you do it from their location to the PMM rather than the PMM to their location,
Yeah.
the current location of the plane.
So it just, so they would be, yeah, we do it from the current, or from the location right there.
Okay.
So this would be PMM.
So if it said 90 instead of 270, would it be coming from the west then?
Would be 45 miles this way. The pirate would have
Right.
But that
It starts in the east, but you would say west because of where it's going, right?
Did I
Because
say
270 is west.
270 is west?
'Cause-
Sorry, they're 45 miles west of PMM.
okay, that's what I was confused about too. I was
Sorry,
like,
I
that seems like it
misspoke.
would be west.
Yeah, I totally
Okay.
misspoke on that. That's my bad.
Okay,
Okay.
cool.
Yep.
Cool. Sounds good. I understand. Thank you.
Yeah. My bad. Sorry, guys. You can blame that one on me. Let me see if we can find more PIREPs. Okay, so this one is over TOP. Guess that's probably a VOR in Kansas City Center somewhere. And then, so they're actually just over it. So they're straight over it. The time is 10157 Zulu. Flight level 340. Type, they're in an A321. Turbulence, light to moderate chop. And then it's just a little remark. Need more. Let's just go find the real winners. There's got to be some good ones somewhere. Southwest is actually notorious for having funny pi reps. This is kind of a boring one, but so this is right around GCK. So they're over, so 004, so they're 55 miles north of LBL. Time is 1540 Zulu. Flight level 15,900. Type an SR-22. Okay. I don't know why they reported a pi rep, but sky's clear. Air temperature is 4. This is a weird pi rep because I don't know why an SR-22 is at 15,000. Anyway. I don't know if I've ever seen a wind report in one. But occasional light turbulence, clear icing. Yeah. All right, let's take 10 minutes. I'm going to try and find some more. And so let's come back and be back at like 8:20. I'll see if I can find a list of some.
Sounds good.
I found some and I was looking in the wrong place. So, also forgot I was supposed to have y'all watch this video. I posted it in the chat. Watch from 32:35. It's right here. And then once you get to like 43:20, the rest is kind of interesting if you wanted to watch it on your own time, but it's not like super important. This just kind of goes over a lot of the charts that we went over. But so yeah, I posted that in there, and then
32:35.
yep, start at 32:35. Rex, did you get that? Can you see the chat still?
Sorry, I just logged in. I'll look again.
it's just a video I posted. I wasn't sure if you wanted me to resend it or not, just because you just logged in again, but or if you could see it.
Yeah, I don't see it. I'm sorry.
No, that's all right. There you go.
Thank you.
Yep, you got it. Yeah, start at 32:35 and then stop watching at 43:20. You'll kind of tell the charts change from stuff we looked at to different stuff.
Thanks, Davis.
You bet. Oh, sorry, I meant to share my screen here. All right. Some of that stuff is the same. Some of it's different. If you look, I've pulled up. So a lot of those SIG weather progs are a little bit different on WSI. They just look different. This is the one for the National Weather Service puts out. Most of the weather that you look at is going to be your METAR and your TAF. To be totally blunt and honest. But one of the big things, if I had to go through and rank these things of like what you would actually use, I actually do use my surface analysis to see where like high pressure systems are and see where the fronts and everything are moving. I do use my TCF. I use this sometimes during the winter just to kind of see, oh, it flipped. Just to kind of see where the jet stream's at. I do use these as well, the thunderstorm probability and the severe weather outlook. Most of the other stuff would be like very few and far between. Okay, so I found this website, and it kind of gives you a little more information, and it also shows you more about, I guess it gives you everything like kind of typed out. A lot of this stuff you're going to want to know. You're going to want to know how to read a PIREP. Also, they found the PIREP like just an amazing PIREP to use for their example. They probably just made it up. Also, the PIREP that we were reading earlier about the SR22, I totally was wrong about what an SR22 is. That PIREP was very normal. But anyway, so when I go over this, UA, just a regular PIREP, like I was saying. UUA is urgent. They say routine and urgent. I always just see UA, and I'm like, that's a regular PIREP. OV is the location of the PIREP. TM is the time. FL is the flight level. TP is the aircraft. SK is sky cover, temperature, wind, turbulence, icing, remarks. So they kind of go over this one here. So we've got a routine. So how we were saying, how I total, oh, come on. Why is it not? Zero or 360, 90, 180, 270. Okay, so YSP might be like Ypsilanti, I think. Nope, totally wrong. Marathon, Ontario. So 090. So we're looking over here. 25 miles. So we are purple. So YSP is right here. That's our center right there. That's where YSP is. We are 090, 25 miles from this. So 25 nautical miles east of Marathon. So we are 25 miles over here. We'll just say that this is our plane. Horrible plane, I know, but so we're 25 miles east over here. Type BE99. It's like a Beechcraft 99. Our sky condition. So basically what he's saying is that it's broken from 2,000 to 4,000. And then there's another overcast layer at 11,000. So the bottom of this cloud base is 2,000, top of it is 4,000. So that means he basically climbed through it, and he was able to tell us where the top of that was. And then there's another overcast layer at 11,000. Temperature is negative 14. Wind 030 at 45 knots. Turbulence, moderate clear air turbulence from 6,000 to 8,000 feet. So he probably climbed through that, clearly, because he got up to 11,000 feet. Icing, light rime from 2,000 to 4,000. And remark, light freezing rain in cloud. Did anyone have questions about that? Most of the time when you're looking at this, so like at SkyWest, when I'm looking at this and I see this PyRep like pop up and I'm trying to figure out like, okay, is this important to me? I would immediately look at this and I'd be like, a Beechcraft 99? That's probably a really small plane. And let's find out. Well, I don't know. Maybe something to look at. And then when I'm looking at it, where'd it go? I'd start looking at flight level. So they'll pop up all the time. We might be flying right over this at like 34,000 feet. And as soon as you look at this and you're like 5,000 feet, does that really matter to me? No, doesn't matter. And that's, I mean, 99% of the time, that's where you stop. It's like, does this apply to me? No. All right, move on. But there are also a fair amount of times where you look at it, it's like, okay, 34,000 feet, type A321, and then like, especially during the winter, you get a lot more turbulence during the winter because the jet stream is so much lower, and it'll be like severe something, and it's like, okay, so let's see if we can avoid that area, or if our pilot's already flying there, let's give him a heads up and he can sit the flight attendants down, make sure everyone's seated, has their, buckled up, maybe deviate around that or change flight level to not go through severe turbulence. There's a lot of things we can do there. Okay. So let's see if we can find some good ones. Do you guys see any urgent PyReps? So immediately we can look down this list, and do you see any UUAs?
Yeah, is that Reno?
Yeah, Reno.
Yeah, I don't know why. I typed in ZTL, give us this Reno. Reno is notorious for low-level wind shear and turbulence. So UUA, that's urgent. So we'll look at that one. Does anybody want to try and tackle this? Take that as a no. So let's just look at it. Let's say I've got a flight to Reno and this thing pops up. Immediately I see UUA and I'm like, oh, it's urgent. Let's see. Does this apply to me? Flight level 010. So okay, it's probably on final. It's an A319, so it's a big plane. So yeah, this probably applies to me. So A319 reported on final for runway 34, low level wind shear, plus or minus 5 knots at 1,000 feet. I guess that's just why they're saying Delta Airlines 3329. Well, anyway, they're just low level wind shear in Reno. That's what we're worried about. Doesn't look like there's any more. When you look at United's PIREPs, United has like a different system than everyone else. So when they report something, it's totally different. I have no clue why they would do that, but maybe it works better for them. Let's see if we have got any real good ones in here. Brian, why don't you take this one away from us?
All right, so we've got O'Hare.
Yep.
At 0141, flight
Yep.
level 900 feet.
Yep.
Type Airbus A319. And now SK, so OVC, that's overcast, right? At 900
Yep.
feet?
Yeah, it's the sky condition, basically.
Sky condition, okay.
Sky condition with a K. Just think of it like that.
Sky condition with.
Yeah.
All right, overcast at 900 feet. Now, so I get the during descent on final runway 10C, but what's the RM?
Remark.
So
basically what they're saying is they're putting that PIREP out there for other pilots so they know, okay, I'm flying through the clouds. When's this going to let up? Well, it's going to let up at 900 feet. So that's when they can expect to see the runway. There's not really much. Hey, here we go. Who wants to go over this one? This is a pretty easy one. Somebody grab this one. I'm gonna have some of you do some PIREPs, and I'll have some of you do some questions on TAFs in a minute. All right, how about I'm just gonna go down the list here. Katie, why don't you read that one for us? Is she here? Nope, picked a bad one. My bad, Katie, if you watch this later. Casey, why don't you grab this one?
All right, I'll try. I'm not really too confident with any of these yet.
Well, that's why we're doing it. I'm not trying to like embarrass anybody here, but
No, you're good.
These are. It looks daunting, but the big thing that you want to get out of them is, okay, flight level, type of aircraft, what happened. But yeah, go ahead and take a whack at this.
That 3200. I'm not sure what that is.
So
to be honest.
320. So where is that? If we're looking on a compass, where
Oh,
would
is that
be?
just direction and then the
Yeah.
speed again?
Yep.
Okay, now. Okay, I got you on that.
So, well,
So it'd be
no, it's not direction and speed, direction and distance. So these last
Distance.
three numbers are the distance.
okay.
So this is what we're basing so our plane is flying. So we have our plane. Well, I'm just going to go ahead and make my compass here.
What city is BNA?
Nashville.
Okay, I never guessed that.
Yeah, Banana Nashville.
Sounds like Banana City. Where's that?
So if we're looking on a compass, and this is either 0 or 360. So if we're looking on a compass, 320, 90, 180, 270, 320 is going to be, we'll just say that our plane is somewhere up here.
Okay.
This is a toddler drew this. That's a beautiful Canadair regional jet 700 series up there. So that's where we are. Nashville is right here, right in the center. So that's what we're basing off of.
So they're 30 miles.
So, yep, they're 30 miles northwest of Nashville.
Gotcha. Okay, and then TM is time, correct? Yep. And then 208 I haven't caught. I'm not sure.
208 Zulu, so time. Just
okay. Okay. And then the flight.
Yep. Flight level.
Or the flight is flight level the same as the altitude?
Yeah, that's just
FL
the altitude. Yep.
Gotcha. So that would be 10,000.
Yep. Flight level 10,000.
10,000, and then type is the CRJ 700.
Yep, that's our beauty.
Sweet. And then turbulence, I don't know. Is it moderate chop?
Yep, moderate chop.
Okay. And then those other two, I have no idea.
From 10,000 to 8,000.
Okay.
So he was probably descending. He's probably flying, I don't know, from Denver to Nashville and probably descending down. And from 10,000 to 8,000, he reported moderate chop.
Okay, that makes sense.
So if you saw that and you had a plane coming toward Nashville, you'd be like, hey, possible moderate chop from 10,000 to 8,000 during descent.
Okay.
Yeah.
Maybe I knew more than I thought.
Yeah. No, you did good. A lot of what we're worried about with these as dispatchers is how can I relay this information to the pilot? Like why is it important for him? And the big thing is that we're worried about first off, our own kind, our workers. So, we have flight attendants that are working the flight, and they're going to be up walking around. Well, if you're sitting in your seat strapped in like you're supposed to be as a just a passenger, you hit a little turbulence, you bump up, seatbelt's going to catch you. That's no big deal at all. If you're a flight attendant and you're walking with a 100-pound cart in front of you and it pops up and it lands on your foot, or you hit really bad turbulence, and this actually happened on one of my flights where I had a flight attendant and we hit some turbulence, and she, like, the plane kind of jostled like down and to the side, and she fell into the wall and hit her head and was like knocked out. Lucky for me, I had actually planned them based off of my hazards page here. So say they were flying through this, I actually planned them below what the this said, so they were planned at like 30,000, and I also had it remarked that there might be turbulence there. So, and they climbed up anyway. The pilot did a little higher and hit some turbulence, and yeah, she got kind of. I think she ended up going to the hospital. But that's what we're worried about there is we want to prevent injuries. So if they were coming up on this and we saw a PIREP like that, you know, can we send them our crew like, hey, let's, you know, there's possible moderate to severe turbulence up ahead from this flight level to this flight level, starting here, ending here, or there's a PIREP up ahead, like maybe just go ahead and, you know, just kind of give them a heads up about it, and then they'll call back to the flight attendants. They'll have the flight attendants sit down. They'll turn the seatbelt sign on, and you know, when you're up at 34,000 feet, like there's not much. You know, you hit a little turbulence, and the plane gets jostled around, but it's not going to like fall out of the sky. So they can fly through things, but you don't want them to fly through things while the flight attendants are up walking around and doing their thing, or while, you know, everybody's up and maybe going to the bathroom or something. You want to give them a heads up as much as you can about turbulence. That's why it's important. And you can, you know, plan around different turbulence reports and things like that. Let me find another one here. A good one. These are also really good during the winter when somebody starts reporting icing. Okay, who's next here? Wes, you're probably pretty familiar with PIREPs.
Actually, not, but I'll give it a go.
No? Okay, well, none of us are, so. Yeah, give this one a go.
I'm not sure which airport that is.
You know, I'm not sure. It might be a VOR. It might not even be an airport. Just OMN.
Okay. Yeah. OMM at radial 270.
So tell me, just kind of briefly, like, tell me, where are we at compared to ONM here?
So you're eastbound.
Well, we don't know which direction we're going.
Well, 270 is west.
Yeah. And then we have our distance.
West. 33 knots.
So we're 33 miles.
Oh, miles. Okay. So
of OMN.
Of OMN. Time is 2:13 at flight level 36, so 36,000 feet.
Oh, my computer just did a weird thing. Sorry.
Whoa. I lost it. Can you highlight it again?
Yep. Let me find it. There we are.
There we go. He has turbulence in an Airbus 320. Something light, choppy.
Yeah, so continuous light chop.
Continuous light chop.
Yep. So this one's pretty good. I have no clue what airport this is. It could even be like a VOR or just something. Well, actually, no, this is probably an airport. But like this is the D&J, that's just a VOR, I think. Unless there's a small airport there. Who wants to crush this one here?
I'll do it.
All right.
So he's 45 miles, like southwest
Yep.
of the DMJ at 212 Zulu, flight level 230, which is 23,000 feet. He's in a E75, and there's turbulence, continued light chop, whatever that.
During climb.
During climb.
Yep. And DURGD is during descent.
Okay.
Yep. So during climb. You guys will catch on to a lot of this stuff as the more you use it. And then that's just the center that put it out. All right. Do you guys have any questions about this? Do you feel pretty comfortable with it? Does anyone not feel comfortable with this?
I'm not comfortable with it, but it's just because I need practice.
Yeah. You'll just once you do more and more of them, once you see them a lot too, and half the time, it's stuff that's like actually written out. So sometimes you'll actually see. Let me see if I can find some.
There was like Alpha Foxtrot Quebec or something. You'd like, I don't know.
Alpha.
Alpha
Where?
Bravo Quebec. I'm sorry. It's like 2 or 3 up.
Oh, Albuquerque there? Yep. Yeah,
Yeah.
I mean, they just wrote stuff. Remark, light chop, Albuquerque through FTI, then smooth, flight level 329. So from Albuquerque to FTI, light chop, and then it was smooth after that. Southwest is actually notorious for putting out like really funny PyReps. And you'll see like they just kind of break the form, which is cool. I think it's really funny. Sometimes you'll see them pop up. It's like, I wonder, who that is. Yeah. So here, this is probably. So does anybody want to try and take a whack at this one?
I'll take it.
Alrighty.
Denver. It's not that urgent because there's not 2 U's, right?
Correct. So this is just a routine one.
Okay. It moved. Okay. So they're at 245, 40 miles from the Denver airport.
Yeah, so that's like 45 miles southwest of Denver.
I'm still learning the compass. Sorry.
No, you're good.
The time is 15:08 Zulu. Flight level 37,000. TP. I don't know TP.
It's the type.
Type. DC-10.
It's a big plane.
TB Mountain. I don't
So
remember TB.
turbulence is moderate. Moderate. Okay, so moderate turbulence, and then it goes straight to remark.
Okay, and then moderate
Mountain wave.
First officer had white caps and coffee.
Yeah.
From the ZDB.
Yeah.
I mean, it's not that funny.
Huh?
I mean, it's not hilarious.
No, it's not funny, but in the world of aviation, aviation can get very
dry.
Dry, yes, and it's a very conservative industry, and so when there is stuff like that every now and then, it'll get sent around the whole office so quick, and everyone just kind of like thinks it's funny. So Yeah, first officer got white caps in his coffee. Like,
Oh,
yeah, all right. Tara, you're getting a B in this class. Not getting an A.
maybe a B minus. You haven't seen me be sarcastic this whole time.
Yeah, B minus at best. Okay, you got to start
At
laughing at
best.
stuff more now.
Keep making jokes like it's always funny.
Okay, this one's
Funny.
pretty funny. Oh, this is right up the road here. Let's see. Who wants to do this one? Cedar City. Anybody from Cedar City?
I am.
It's all you.
All right. Is that KCDC highlighted?
Yeah, CDC is just the highlight. That's the highlight of it, so you know which one.
Cool. Urgent. Urgent. What was UA?
UUA is urgent and UA is routine.
What did it stand for? Urgent what?
Oh, I actually have no clue.
Urgent upper air.
Urgent upper air.
Okay.
Perfect. Over Salt Lake City, Cedar City.
So that's probably just a city pair.
Yeah.
I think I actually remember this one. No, I don't.
Time is 0332 Zulu. Flunkin.
Yeah, so there's another over Flunkin. Flunkin is like a that's just like a fix or a I can't remember if it's some sort. I think it's just a waypoint.
Okay.
It's right up there.
Type E120. Turbulence continued, moderate, occasional, severe. BLO. I don't know what that is.
It's just
Below.
Yeah, below.
Yeah. Below. Flight level 260. Remarks had some screamers in the back. Nice.
So, I mean, there are some that are just kind of funny.
Escaped SeaWorld.
Yeah. Person reported hawk flying backwards.
There's one there that says the severe icing caused both engines to stop. Is that true? Could that happen?
I have severe icing causing both engines to stop. It must have been cold. I don't know. Over Sun Valley?
They ski up in Sun Valley.
SW3. I wonder what kind of plane that is. I don't know. I didn't know that was like possible, really. Okay. But anyway, a lot of times when you see the funny ones, though, they're from what I've heard and what I've seen. A lot of times it's Southwest. Southwest is probably the more relaxed company of all of the regionals and major airlines. Okay, let's look at some TAFs. And I'm hoping that I'll be able to find some bad ones. What was it K-Mobile that we were looking at earlier that was had bad weather
Yeah,
this
but I
morning?
don't think it's K-Mob. It's something different.
Mobile?
Oh, maybe it is. Never mind.
We do a lot of flying in there. I don't want the NOTAMs, snow tams. Don't want those. I want the Pyrex. Don't want that. I'll take the fast 10. Oh, it's not what I wanted. I was hoping for something bad. Maybe we got some bad ones in here. Okay. So we're flying to Houston, and let's just say our estimated time of arrival is 0531. Actually, no, we're going to go with 0431. So okay. Our minimums in Houston are, let's say that there's a whole bunch of NOTAMs, and our minimums there are 2 miles and 700. So 2 and 700. 2 miles of visibility and 700-foot ceiling. Are we legal to go? You guys went over TAFs and everything last night, right? Bueller?
Yes, we did.
Okay. Let's do a quick refresher, though. So on the 22nd at 0324 Zulu, this was issued. So it's valid from the 22nd at 3 Zulu till the 23rd at 6 Zulu. So wind is 330 at 10 knots, 5 statute miles of visibility. BR. So we've got mist, VCTS,
Thunderstorms in the vicinity.
thunderstorms of vicinity, overcast 600, and CB. Just a cumulonimbus cloud. So this we're looking at here, the valid time for this line is from 3 Zulu until the next line. So our next line is actually a tempo, so it would be this line. So from 3 to 5, we have this. So a tempo is what's called conditional language, and that's just saying that there's a temporary condition within here that is going to be a little bit different than up here. So from 4 to 5, we have 2 statute miles of visibility and thunderstorms with rain.
No, we're not legal to go.
Well, actually we would, because we only dispatch off of visibility. So we have the 2 miles of visibility. Now, would they actually be able to land? That's a different story, but we would be legal to go because all we need is the visibility. I know that is completely backwards, but that's kind of why I made that question. So then from 5 till 10, we have 360 at 6 knots, 3 statute miles of visibility. We still have mist. We still have overcast 400. So it actually gets worse at 5. So in Houston, I think we even have Cat 2. So it's probably like legal to go is probably like a quarter and 100. That's probably what our mins actually are. So still, if we're going at 0431 Zulu, when are we getting there? What's the weather going to be like when we get there?
Gonna be overcast.
Yeah, so we're going to have 2 statute miles of visibility, thunderstorms with rain. Our wind, since we don't have wind down here, we'd still look back up here for our wind. There's probably still going to be mist. There's probably still going to be thunderstorms of vicinity too, but that's another story. And we'll still be overcast at 600. So when we look at this and we're planning this flight, what do you guys might think be? What do you guys think might be some of the considerations we're taking into?
The thunderstorms, the cumulonimbus cloud.
Yeah. So are we going to be able to land in thunderstorms?
Nope.
No. So kind of what we'd be looking at here is, first off, is an alternate required?
Yes.
Yes. So our 1, 2, 3 rule. 1 hour before or after, do we have less than 2,000 foot ceiling and less than 3 statute miles of visibility? We got both of those. We got bad weather here. So we need an alternate already.
Is that 2,000 or 200?
2,000. Yeah. So less than a 2,000 foot ceiling, and we need an alternate. So the other thing is, are we going to land with thunderstorms with rain? No. So if there's a thunderstorm over the field, no, they're going to shut down the field. They won't let anybody land. If it's it's like a bad thunderstorm, it's just rain, they can still land in the rain. But yeah, thunderstorms, they're not landing. And so probably what we're looking at here is we're going to throw some hold fuel on, because they'll just hold the planes in the air. And then after the thunderstorm passes over, they clear them in. And that was the most simple way I could have possibly put it. So we'd want to plan some extra hold fuel for that. They, in our TAFs, happens all the time where they say thunderstorms with rain for an hour, but those thunderstorms might only be over the field for 15 minutes. So do we still want to send the flight? Yes. We'll still send the flight, but we'll give them extra fuel. If we saw that it was like this huge mass of thunderstorms that was heading toward them on the radar, and it looked like it was going to shut down the field for an hour, and there's just no way to get through it, no way to get around it, nothing like that, then, you might think about delaying the flight, something like that. But definitely what we'll be looking here is, well, we already require an alternate, and then we'd put some hold fuel on. So if we were this whole thing, is there any point in the TAF where we don't require an alternate?
I think the one at what is it, 007? No, that's not the 1000.
This one?
Yeah, I think we're good there.
So,
So did I just kill a plane?
well, you didn't kill anybody. They'll probably still land.
That's good.
Yeah, I mean we've got great men's in Houston, but so do we have a ceiling? So we're looking at 1, 2, 3. So do we have a ceiling less than 2,000 feet?
No, we
Yes.
Yeah, we have a ceiling
Yeah.
less than 2,000 feet. We've got overcast
So-
500. So we don't have. So the first thing we're looking at is ceiling. So 1, 2, 3, 2,000 feet ceiling. So automatically we have to have one because of this overcast 500. If this was scattered 500, we wouldn't require one from 11 to 23. But since it's overcast, it's a ceiling for us, and we are required to have an alternate. Now we've got great viz, 6 miles of visibility. That's as high as it gets in a TAF.
Okay, but since it's a TAF, it's a forecast, so it's not necessarily the same as a METAR, which is more relevant, right?
Yes, correct. But if our estimated time of arrival was like within this window, we'd still have to have the alternate. So even if we were looking at a METAR that was 10 and clear for 03, say okay, so with our arrival of 0431, say we're looking at a METAR that just 10 and clear, beautiful, but the TAF still looks like this. This is still forecasted, so we would still have to have an alternate.
Okay, so you want to play it safe regardless, even if the other is more pertinent.
Yep.
Got it.
Yeah, because conditions change all the time. Okay, let's find a new TAF here. Can anybody tell me what this is? This thing, people get this wrong all the time, so.
Is that wind shear?
That is wind shear, yep. So wind shear at 2,000 feet at, so 050, wind from 050 at 40 knots. Everyone always thinks this is wind shift at 2,000 feet, but it's wind shear.
I would have guessed wind shear from 020 to 050.
Oh, no, it'd be wind shear at 2,000 feet. So you're coming down, and the wind is probably similar to this. And then at 2,000 feet, it's different. Or actually, when you're coming down, it's probably this. And then at less than 2,000 feet, it changes. I mean, it could be any number of things, but yeah, this is wind shear, 2,000 feet. Okay. So let's look at O'Hare. This one. At any point in this TAF, do we require an alternate?
No.
You sure?
Now I'm not.
Okay, so 1, 2, 3. So 2,000-foot ceilings would be our first thing we look at is our ceilings. Well, actually, first thing you can look at is honestly the visibility, because that's just really easy to go down here. You see 6, 6, 6, 6. We're good. Now we're gonna have to look at our ceilings. Do we have a 2,000-foot ceiling? It's a few. That doesn't really matter to us much anyway. We've broken at 3,000. That's getting kind of low. Overcast at 2,000. So it's not below 2,000, but it's at 2,000. So we wouldn't require one there. We have scattered at 8. Scattered is not a ceiling for us, but it is some low clouds. And then we have overcast at 1,300. So this guy is right here, requires an alternate. So this is valid from 2203 to 2306. So what time of our arrival would require an alternate? So from what to what? Does that make sense? So if this is our ceiling 1 hour after or 1 hour before our arrival, we would be required, this line would require us to have an alternate from 02 Zulu, so 1 hour before this, to 1 hour after this. So from 02 Zulu to 0700 Zulu is when we'd be required to have an alternate for that. Does everyone understand?
Where did you get the 700 Zulu?
So our valid time for this TAF is right here. So from on the 22nd, 03 Zulu, till the 23rd at 06.
Oh, an hour before, an hour after. Huh?
Yep.
Okay.
An hour before,
Okay, I
and
understand.
an hour after. Yep.
Okay, I gotcha. Thank you.
Is that not an hour?
007?
What'd you say?
0007 Zulu? That's an hour after 2306.
So 23 is the date. So the 22nd.
Okay.
So this.
Is that not 1 hour before or 1 hour after ETA?
Yeah. So what I'm saying is if our ETA was from 02 to 07, we would need an alternate.
Okay.
So if our ETA was inside this, it would need an alternate. If it was 0159 on the 22nd, we would not technically be required to have an alternate. Might put one anyway if you wanted to, but it's up to you. But this is when we would be required to have one. Let me see if I can find another example of that. Okay, so Seattle. Do we require an alternate on here at all?
No.
Yes.
Yes.
From 03 to 07, we'll have 1 statute mile visibility.
Yep. So from when would we need an alternate? So if our ETA was X to X, when would we need the alternate?
02 to 08.
Yes, correct. So 0200 Zulu to 0800 Zulu. So that's 1 hour before. So, well, we would need it up here as well as in our conditional language down here. So it's 1 hour before this line and then 1 hour after this line. So here our ceilings are supposed to go up to 3,000 feet. So we're not required to have one anymore. And then the rest of the tap doesn't require one either. So from an hour before to an hour after, we would be required, if our ETA was inside that, we'd be required to have one. So does anyone get why? So this line stretches from 3 to Zulu to 7 Zulu, and this tempo covers from 3 to 7. So does anyone get why they wouldn't have just put up here that this line would just be the main body?
Kind of a sub note.
Yeah, it's basically just saying that the snow's going to get better and worse for like 3 hours. So tempo is not necessarily like that it's going to be that. It's just saying that temporarily it could be. All right. Kind of out of time here. Does anybody have any questions on that? Or any questions on anything we went over today?
I'm good. I think I just need a little practice. That's all.
Yeah.
Or a lot.
Yeah.
Yeah, I guess a little is.
And this is, I thought we were going to get further into this sheet. We kind of ran out of time, but we'll talk about more of it. Alrighty. Well, if nobody's got any further questions, I will talk to you all probably next week.
Okay, sounds good. Thank you.
Cool. Thank you.
Thank you.
Davis?
Hey.
Quick question. Are you working this week?
Yeah, I am.
You're at SkyWest.
Thursday, Friday, Saturday, Sunday, and Monday.
Just wondering, I was visiting with